and that we call a right-angled triangle. Then we shall also introduce the concept of a circle, which circle is going to be divided into four parts, and which four parts we call them quadrants. I think in your introduction at school you must have come across that word, the quadrants. Yes. So basically, this video gives a brief introduction about trigonometry, the triangle, the 90 degrees, the adjacent side, the opposite, and all that. So you'll come and go through it. Then even those ones, they talk about sine, cos. Did you look at the special angles, 30, 45, and 60 degrees? To say like cos of 30 is equal to maybe a half.
There was this thing where there was like something like act, some formula. Yeah, we did some part of it.
No, not that one. That one. So the acts is the one that is summarized by this image here. Okay, where we have all angles all the ratios being positive in the first quadrant, and the sine in the second, tan in the third, and then cos in the fourth quadrant. So that is the acts. Then we have the one which talks about the special angles. I think it is also somewhere in one of the videos. So the acts is here. So that here all are positive. Here it is sine and maybe cosecant, which is positive. But here it should do, our emphasis should be on all, then sine, tan, and cos, because these other ones are the inverses. 1 over sine gives you cosecant, then 1 over tan gives you cotangent, and 1 over cos gives you secant. So, and our angles are measured from the x-axis and clockwise. So we move in an anti-clockwise direction. Okay, then when we come to right angled triangle, so this one we already know, if this is the angle and this is the 90, this side which bears the angle, and the 90 degrees is the adjacent, then there is an opposite side, and then the longest side is the hypotenuse. So that one I think we already know about it. Then we have sine, cosine, and tangent. That one I think you covered. So from our O level. Then this one I had briefly talked about it. The inverses of cos, sine, and tan. When we get 1 over cos, it gives us secant. Okay. Then 1 over tan gives us cotangent, and 1 over sine gives us secant. Okay.
Yeah.
And those ones. Then majorly, maybe we are going to begin from the Pythagoras theorem, and we can share. How does Pythagoras state?
It is a is equals to a squared is equals to b squared plus c squared.
A squared.
A squared is equals to b squared plus c squared, of which a is okay. Yeah.
A is yeah, so a squared. So when we get the squares of these short sides, they give us the what? The square of the longest side. Okay.
So you don't
So going
see.
back into, yes, the c is also supposed to be squared. Okay. So when we go back to our triangle where we have the acts, okay. So if we drew this and we drew this, so this is x, this is y, and then we have our circle. Okay. So if we picked a point here, and then we tried to make, so this would be x, this would be y, and then this is the angle. So automatically this would be the radius. Okay. So now, what would sine of the angle be? What would this one be equal to?
B equals to y. Let me see. I'm not sure.
Yes. Sine is opposite divided by hypotenuse, so it should be y divided by r. Okay. Are we there?
Yes, yes.
Yes. So we at the end we want to substitute it in this equation. So meaning here we expect to have x squared plus y squared is equal to r squared. So here we are going to make y the subject. So when we multiply, y is going to be equal to r sine of theta. Are we there?
Yeah.
Then we also get the adjacent one, the one that is in x. So this is adjacent and hypotenuse. So that would be cos of theta is equal to x. I will divide this by r. So likewise x is going to be r cos of theta. And then we shall now come and substitute the values of y and x in this formula here. So it will give us r cos theta. So we square this one plus y, no, plus
R sine.
put a bracket plus r sine theta, then we square this and it gives us r squared. Are we there? So this when we
Yep.
open brackets here, it is going to be r squared cos squared theta plus r squared sine squared theta is equal to r squared. Okay.
Yes, yes.
So here we can see that r squared is common, so we can divide by r squared still here, and then r squared here. So this would give us 1, and this one would also go. The r's, all of them disappear, and we remain with cos squared theta plus sine squared theta is equal to 1. Okay.
Yeah.
So this would be our equation 1. or identity 1. Okay, so they are going to B3, which we measure using in trigonometry, in the Pythagoras theorem. So we are going to get this equation and we divide it by cos. Okay, so we shall divide by cos, and then we also divide by sine. So dividing by cos, we shall have cos squared theta divided by cos squared theta, then plus sine squared theta. We divide this by cos squared theta, and is equal to 1 divided by cos squared theta.
Master.
Okay, this one would give, yes.
What are you dividing? How are we dividing by cos theta throughout?
Yes, I'm trying to derive other identities using this first identity.
All right.
So we are going to first divide by cos, and then later we divide by sine.
Okay.
Okay, so we know that sine over cos gives us, what is sine over cos?
Sine over cos is it will come back like that.
Tan. Sine over cos is tan. So this gives us tan squared theta, and then 1 over cos, we have just seen that it is sec. Sec, so it will be sec squared what? Theta. So this will be our second what? Will be our second identity. Are we there?
Yes.
Yes. So still getting back our equation, cos squared theta plus sine squared theta equaling to 1. So when we divide now by sine squared theta, we shall have cos squared theta divided by sine squared theta, then plus sine squared theta, then we divide this by sine squared theta, and this will be equal to 1 divided by sine squared theta. So this and this will give us a 1, and the sine over cos is a cot, so it will be cot squared theta plus 1 is equal to cosec. Okay, so this will be our what? Our third. Okay.
Yeah.
So in Pythagoras theorem and the trigonometry, we have 3 identities, which are cos squared theta plus sine squared theta is equal to 1, and then we have 1 plus tan squared theta is equal to sec squared theta, and then we have cot squared theta plus 1 is equal to cosec. Okay, so these three, we are going to use them to solve some of the trigonometrical functions that have squares in them. Okay, that have two powers of 2 in them, and they also help us to prove some identities as we are always asked to prove them, guided by the back house. Okay, so
Yeah.
this is what we are going to majorly focus on for today. Okay.
Okay.
So let us now go back to our notes and check.
Okay. Finished.
So it is here like what we have proved. So if we want to have some of those equations, so you can see sine squared. If we want the sine squared, it is 1 minus cos squared. If we turn one of the other equations, the first equation, and we want to make sine the subject of the formula, then we have cos squared can be also 1 minus sine squared theta. Then tan squared plus 1 is equal to sec squared. Or when you want only tan, you can have it like transfer the one to the other side and it becomes a negative. And then we have seen that cot squared theta plus 1 is equal to cosec squared theta. So if you only want a cot squared, it is equal to cosec squared theta minus 1. So is dou angle and half angle, we shall come to them later. Let me extract an example here that we can try to do. Yes, Kwagala, you are welcome.
Thank you, sir.
Yes. How are you?
I'm fine, thank you, sir.
Yes. Had you covered the trigonometry at school?
Yes, we had a half of it.
Yeah, a half of it.
Yes.
Yeah. So how was it? Was it simple?
No, it wasn't.
Sure.
No, it was not.
As if it is the one of the good topics to enjoy in paper 1.
No, it's
It is
not.
not.
No, to me, it's not.
What do you enjoy most in paper 1 so far?
Integration, polynomials, and maybe studs.
And thirds.
Yes.
Okay. It is also enjoyable, so only that you haven't liked it.
No, it was not good.
And had you covered Pythagoras theorem, the likes of cos squared plus sine squared
Yes, we
is
had
equal to
covered
1?
that. We had covered that part.
So let me put for you an example and you help us. Okay, write this one. 1 plus cos theta is equal to sine squared theta.
Pardon, sir?
1 plus cos theta
Yes.
is equal to 2 sine squared theta. Do you know how to screen share?
No. My page has not yet worked. I've just joined.
The Zoom page.
No. Oh, Zoom, as in Zoom. No. Zoom, I don't know.
Sure. Okay, let me come. But there is something like an arrow there pointing upwards. Have you seen it?
No.
Okay, let us do it here then. So what was it?
It's 1 plus cos theta is equal to 2 sine squared theta.
Is equal to 2 sine squared theta. So what are we going to do? Arvin,
Yeah.
what are we doing here? So Emily has gone off. So what we do, okay? This equation has its highest power is a 2. So that means it becomes a quadratic equation. Is that understood?
Yes, yes, yes.
Yes, and in solving a quadratic equation, we have our methods of factorization, completing squares, and the like. So here we need, and these terms it is in 2 variables. So we have cos and sine. But the most appropriate way would be to have a quadratic equation is to have it in 1 variable. So we can't have it in cos and as well have it in what? In sine. So what we are going to do is to convert this sine into cos such that, because we can easily convert it using cos squared plus sine squared is equal to 1. Are we there? So here we can easily remain with the sine squared on one side, and the cos moves to the opposite side, such that now our sine squared is equal to 1 minus cos squared. So now after getting this one here, so we are going to transfer it to our equation. Because our equation has a cos that is not squared and a sine squared, so it is the sine squared that we can easily substitute for using the Pythagoras theorem identities. So after making a sine squared equal to 1 minus cos squared, then we substitute it there, and we have 1 plus cos square, cos theta will be equal to 2 into 1 minus cos squared what? Theta. So here, after, when we get here, we are going to just open brackets. So 2 times 1 will give us what? 2, and then 2 times cos squared theta will give us 2 cos squared what? Theta. And this one remains as 1 plus cos theta. So what are we going to do after here? What are we going to do after this step?
Collect the common terms.
We collect the common terms. Yes,
Put the
Emile?
common terms. What will happen to the rest?
Yes, Joel, you are welcome. Our highest power B2.
I think the teacher's network. The members, what's up? Teacher's good. Teacher's back.
So we were still solving our equation disconnected. But who can remind us how we had reached?
1 plus cos squared.
No, cos theta
Cos theta, yes, equals to
is 2
minus 2 cos squared theta.
Yes. So what we are going to do now is to have, so we all know that the quadratic equation ax squared plus bx plus c is always equated to what? To 0. Is that okay? So we are going to rewrite this beginning with the term in square plus the term in cos theta alone, then plus these constants. Okay? So when we take this one, this other side, it becomes 2 cos squared theta. Then we are going to add this term, which is cos theta. Then when this one crosses, it becomes negative, so will be 1 minus 2, and that gives us a negative what? And then we equate this to what? To 0. So when we get here, we can choose a method that is convenient for us. Okay? So one may decide to let cos theta to be an x, and then they solve the equation. Or you can work with the cos and the sine. But what is the most important is for us to first get the 2 times negative 1, and this will give us negative what? 2. Then we get two numbers, two factors of 2 that we can add to give us, that we multiply to give us -2, but when we add them, they give us 1, the coefficient of cos theta. So what will those factors be?
Is it what? Is it 2 negative 1?
2 negative 1, yes. Any other suggestion? Joel, you could remove your video because it will consume a lot of data. Okay, thank you. So our factors are 2 and -1. So we are going to substitute them here where we have cos. So that means we shall have 2 cos squared theta plus 2 cos theta minus cos theta minus 1 is equal to 0. Then what would be next? In the steps of solving a quadratic equation,
Factorize out the commonest.
we factorize out the commonest. But before we do that, don't we need to do some grouping? So we can group 2 cos squared theta plus 2 cos theta. So that is one group, then minus cos theta plus 1 is equal to 0. Then after here, we can be able to factorize out to the common factors. So what will be the common factor in this first bracket?
2 cos theta.
2 cos theta. So we shall have 2 cos theta out. Then we shall remain with cos theta plus 1. So the second bracket has already been factorized into cos theta plus 1. And then this will be equal to 0. Then this one is also now common, so we shall write it as cos theta plus 1, then into 2 cos theta minus 1, and we equate this one to 0. So here we can say either the first bracket is equal to 0, cos theta plus 1 is equal to 0. So when it crosses the equal signs, it becomes negative what? 1. And then when we get here, we take the cos inverse both sides. So and theta now becomes cos inverse of 1. So this negative here tells us where the angle is going to lie. Okay. So where is cos negative in the quadrants? Where is cos negative? Yes, Emile?
Sir,
Yes.
cos is negative in the second and third quadrant.
in the second and third quadrants.
Yes.
Okay. So if we could draw our quadrant, our circle here, then put in the quadrants and our acts. So cos will be negative here and as well here. But if we look at this value of -1, so the -1 is here and the 1 is here. Likewise here when we consider the axes. So when you substitute this directly in a calculator, it will give you what? A 180. But when we take the cos inverse here, those with calculators, when you take cos inverse of 1, which value do you get?
Zero.
0. Okay, 0 degrees. But we are saying our angle will lie in the second quadrant and in the third what? In the third quadrant and in the third. So in the second quadrant, our angle is always 180 minus the theta, where theta is the angle in the first quadrant. Okay, this is the 0 that we are getting. So our angle here for values of theta is going to be 180 degrees, and this will give us 180. Is that okay?
Yes, sir.
Then the one in the third quadrant would still be 180 plus theta, which is 180 plus 0, so it would give us the same what? The same answer. So we for cos theta plus 1 equaling that, so it gives us this. So that is for one side of the bracket. Then we take also the other side, 2 cos theta minus 1, 2 cos theta minus 1 is equal to 0. What would be our next step?
Take one to the other side.
And divide by 2, okay? So cos theta will be equal to a half. So then here we are going to find the angles where cos is what? Is positive. So it is positive. In which quadrant is cos positive?
In the first and fourth.
First and fourth. Okay. Then now we shall take the cos inverse. So if cos theta is equal to a half, taking this the inverse, theta will be equal to cos inverse over half. And what is the cos inverse over half?
60.
60. And this will be 60 degrees. So the 60 degrees would be angle in the first quadrant. So we are now going to get another angle in the fourth quadrant. So how do we get angle in the fourth quadrant? Yes, Emily.
So for me, I'm not sure about the formula that you use, because for us we used to just use like arrows, then you add.
The arrows.
Yes, the arrow
How?
method
How?
on the
Arrow
code.
method.
Yeah, like you
Eh,
would draw the quadrant, then you start from the other side of like all are positive. Then you start from
Yes.
there, then
Then you move.
stop. Yeah, like that.
It is the same. So this would be 360 minus. Let me first finish this, then we do that method as well. So this would be 300 degrees. Okay. Then afterwards, we'll set our solution for the whole number. So begin with the smallest angle. So we had 60, we had 180, and then 300. So we shall begin with 60 degrees. Then we go to 180, and then we conclude with 300. So this would be the solution to the number. Is that okay? So maybe Emily, on your Zoom, when that Zoom interface, there is an arrow show going upwards. Have you seen that arrow?
No, it's pointing down.
Pointing down.
Yes.
It's a green arrow
So
that's saying
the
show
one,
on our side of your screen.
Oh,
the green.
I've seen it.
Then when you click on it, first wait.
Yes.
It will show you something. Then you choose the whiteboard. So when you choose the whiteboard, you'll have an interface like this one that is empty. It will come with the pen.
Yes.
All that is hard for you, we can just do it here.
Okay.
Okay. So when we draw this circle, okay, much as it is not well drawn, okay, and so this would be 0, this would be 90, this would be 180, 270, and then when we get back, it gives us 360. Okay. So in the first quadrant, we shall always get the angle, the acute angle, which is theta. Okay. Then when we want to get the angle in the second quadrant, we move like that. Emily, isn't this what you were meaning? The one
Yes,
of
teacher,
using arrows?
it is.
Yes.
Yes, it's
So
the
now we
one,
went
but that
to
method is confused.
which method of the arrow?
Yes, it is. Yes, teacher.
Emily, which
That
method?
one of the arrows, for me, it used to confuse me at school.
Now, it is the same like the other one. Now, this angle here is theta. Let me choose some other color here. So this angle is theta. This one is also going to be equal to theta. And then our emphasis is to get the angle from the first quadrant up to that line. Okay? So meaning to do that, when we have our theta here, it is easier for us to get 180 minus the what? The theta. So this is how you always get angles in the second what? Quadrant. Okay. Then in the third quadrant, this will be still this theta value. It is equal to the angle in the first quadrant. Then you now need an angle from here up to this point. Okay. So because this is already 180 and this is theta, so you'll just add 180 plus theta. So this is angle. This is how you're going to be getting the angles in the third what?
Quadrant.
The third quadrant. This is second. This is first. Then in the fourth, you still have an acute angle here, theta, which is equal to angle in the first quadrant. Okay?
Yes.
So you still move from the positive x-axis going anti-clockwise up to here. Okay?
Yes.
So when we want up to there, and this is a theta, and we have a 360 here, so we say it is 360 minus the what?
The theta.
The theta. So this is how you'll be getting angles in the what? In the fourth.
Fourth quadrant.
Yes. So, but the angle that you first get is in the first quadrant, then being guided by the signs, whether positive or negative, then you locate other angles in the respective what? In the respective quadrants. Okay?
Yes.
Yes.
Teacher,
So
what about negatives?
the negatives? The negatives are guided by this still. They rotate about the circle. So in the first quadrant, we have all the sine, all the cos, and tan. All these ones are what? Are positive. So that is what A stands for, that all are positive. And we number them going anti-clockwise, okay? So here we have C, T, and S. So this is the first quadrant. So we move anti-clockwise, third, fourth, third and fourth. So where you see S, so the S stands for sign. So this means it is on a sign here, which is positive.
Which is positive.
Others are what? Are negative. Yes. So because of time, so that is how it is. But let me first show you something here. When you go back to the site, there are videos explaining. There are videos that explain those or that, okay? When you come and watch these videos in here, they have those explanations, yeah? Okay? So for today, I think we have covered this first introduction to trigonometry. However, for the coming times, because not all of us have at the same pace, okay? Because we are from different schools. I'm going to give you calls, and then we shall be organizing how to meet. Okay?
Yes.
So I'm going to send you some numbers to do regarding this work we have covered. So you can do them and then submit them here on the site. Do you know how to submit your work here in messages?
No.
Okay. So when you open and get to this interface here, you come to messages. Then you'll go on on new message. Okay. So when you click on new message, so there is this other side which is appearing on the right. Okay. So where you have recipient, then they say search member, then subject. So like the what you're talking about, the message you're going to send. Then it has message, so which you can type. So here you'll be searching for the name, and I think most of you know my name. Then after doing your work and typing it, you'll come and choose this arrow, this thing here for attachment. Okay. So when you click on attachment, then it says upload file. So when it says upload file, you click on the upload file. Then it will take you to your computer or somewhere where your work is stored. Then you click on it, you double click on it, and then it comes. Okay.
Teacher, how about if I,
send? Yes.
teacher, how about if I make a PDF and then send it to your inbox?
To my inbox would be okay, but it is not convenient. Okay, for now we can do it, but the best method is to use this.
Okay.
But if it fails for now, but you can try it, and if it fails, you can send in my inbox. Okay. So let us stop here. Other people have a class at 10, and it is coming to time. Thank you. We shall meet again. Alvin, you can end the meeting.